So welcome back, everyone, and I have the pleasure to welcome Jacopo Tagliabue, and together with Patrick, John Kia, he will host this workshop on in-session personalization. And without any further ado, I hand over to Jacopo.
Hi, ciao guys. Thanks so much for taking the time. I will try to, I know it's the last talk of the day, hopefully for you, and you're very tired and, maybe you already have a beer or two. I envy you. This is just, half the, midday for me, and I didn't get any beer. I'm going to leave 1 more minute before I start for people that join to get you the chance to download the data and clone the repo that we're going to use, as we have 2 hours, which is plenty of time for, not just the workshop, but also interacting hopefully with each other. So I'm going to mute myself. I'm gonna get a coffee, gonna be back in 2 minutes, and we're gonna start. If you didn't, also this link are in the chat. So if you want, if you don't want to type them in or Google them, use the chat to do that. And if you don't do that, there's no problem. This is recorded, and data and code is available for free open source. So if you don't want to do it now, because again, maybe you have 1 beer too many, or it's too late, or you're tired, you can follow along. And then you can just, rest assured that you can go back and go to this material at your own pace, because everything is open. Okay, so just so you know. But if you want to do it while we do it, I think it could be a good thing. So I'm just gonna leave it here, and I'll give you a couple of minutes to set you up. Oh, okay. Cool. Thanks so much, Renee. Thanks. Guys, thanks again for joining us. Just gonna be me today, even if Patrick really helped out preparing the workshop. It's gonna be mostly because when we gladly accept the invitation to get this workshop, we didn't realize it's Canada Day today, as me and Patrick are really bad Canadians, as we're actually in fact not Canadians at all, but so it's actually national holiday for our company. So thanks so much again for joining us. This is Jacopo from Coveo, and we're super happy. I can't see the chat while I'm speaking, as I'm probably going to be busy entertaining you, but I'm really easygoing. So if there's anything you want to ask, you can just unmute yourself and ask stuff. Like, don't be shy. It works much better than if you wait for me to actually, see the chat or doing anything. I'm super happy with you asking questions at all time. No problem. We have 2 hours, so which is a lot of time. And we'll try to make this, hopefully a bit fun and productive for all. We have, as specified in the abstract, we have 2 main sessions. So 2 main parts. The first part is going to be more of a product and slides, which is the part we're in right now, and is going to discuss our view of how to build personalization for e-commerce. And we present our view for several reasons. One of that is that a lot of the research and a lot of the things that has been done in the last couple of years have been all coming from few players. Alibaba, Amazon, Etsy, eBay, which may or may not be representatives of what you guys or other type of practitioner actually see every day. So one good thing I think about our roadmap is that our roadmap is slightly more democratic, and hopefully there's something here that you can take away and use, starting tomorrow in your company for your own e-commerce problem. The second part is going to be more hands-on. It's not going to be terribly technical, but actually there's going to be code involved, and we're actually going to go a bit through the code, and it's going to basically tell you how to build some of the models we will be discussed, some of the use cases. It's going to show you working code that builds, let's say, a baseline version for some of these use cases. Again, the code is released in an open source fashion with the data, so you can play around with it as much as you want. And if you have any question either today or later on in the next following days, please reach out to us through LinkedIn or email. We're super happy to help. Let's get started with the presentation. So very happy to meet you. I'm Jacopo. I used to be the founder of a startup in Silicon Valley. It was called Tuso. Tuso was acquired by Coveo, what was now 2 years ago, to enhance basically the AI capability of the company. And to kind of bootstrap the digital commerce offer of Coveo. What we do in the AI team at Coveo, we have a significant research roadmap in all the main topic related to information retrieval, artificial intelligence, and natural language processing. Last year, you may have found us in any of these top conferences. If you're gonna come to Seeger next week, we're gonna be there. If you're gonna come to ACL in a month, we're gonna be there as well. We got also 15 minutes of celebrity a couple of weeks ago when we actually won the best paper award at NACL. It's pretty cool, consider that the competition is, again, the Amazon and Alibaba of this world. And while we're a big startup, we're still very, very far from that level of either funding and data. So this is a paper that we will discuss today. And finally, we are also the organizer of the Data Challenge. The Data Challenge has been actually closed, so it ended last week, and it saw the participation of some of the best company in e-commerce, including Zalando, Grubhub, Nvidia. They have a recommender system team, Rakuten, and so on and so forth. Why is this relevant? Well, this is relevant because the data that have been released for the Data Challenge is the richest and biggest e-commerce data set that has ever been released for research purposes. And so we're super happy to release it, not just for the Data Challenge, but generally to the AI and e-commerce community. Today, we're actually going to work with this data. And this is not movie lens data. I cannot stress this enough. This is not data that is random data that has been benchmarked and overfit for 10 years by the community. This is real data from an e-commerce that is representative of what we call the middle tail, like outside of few giants, but not this small Shopify commerce. Finally, a word about us. We're never going to talk about Coveo anymore. So sorry for the marketing slide, but it's oh, sorry. Can you still see me? My computer got crazy. Sorry about this. So yeah. So we're not going to talk about Coveo anymore. And the only thing we want to say is that, if you don't know us, we're a North American unicorn, mostly based in Canada, but we have offices also in New York, London, and San Francisco. And we do a bunch of stuff. One of them is e-commerce, and it's why we have this experience that hopefully we're going to share with you today. Again, sorry for the market slide, but it's kind of I kind of have to do it. What does it look like a Coveo integration? It's what every e-commerce has, right? So when you have an e-commerce, either you build your own search API, the query suggestion, recommendation, the listing, or you buy it from somebody else, or you get it with the platform. That are typically the three big options that you can have, right? So when Coveo is is working on this type of things, our clients will typically integrate one API for each of these use cases, which means that we wouldn't say we're expert in all these use cases, but we certainly have our fair share of experience and an idea on how that keeps things together. But again, this is mostly what any e-commerce setup has. So what we're going to say today has nothing to do with Coveo, either as a company is offering, and has everything to do with AI in e-commerce. And we're super happy to evangelize about that with no relationship with what we do. And of course, if you want to know what we do, please ping us. So one of the biggest topics in e-commerce in the last 5 years has been personalization. Personalization is the idea that two people go to the same e-commerce website. This one is a very famous e-commerce website in Seattle, and they search for something, I don't know, Galaxy. And depending on who you are, so depending on how much this website knows about you, you may actually get a different experience, right? So this is the big promise of digital commerce, right? While if you have a physical shop, you can't really change a shop in milliseconds to cater to different needs of different people. But in e-commerce, actually, you can, right? You can actually morph an entire website, in theory, in real time, if have something about the customer, and you can exploit it to actually make it more likely for them to buy or be more happy, more engaged, and so on and so forth. So that is the theory, and there's a lot of paper research and a lot of hype or Gartner articles about that. You can go and read them. But then the reality is very different. Like that is very different because while everybody agrees that personalization is cool and everybody with their personalization improves basically business KPIs, the constraints that you are working with outside of Amazon makes personalization particularly hard. So problem number one, most shops don't generate massive amount of data. Amazon has approximately 220 million, I think, user per month, which is it's like 6 times the amount of people in Canada, like the country. So which is a lot. Most e-commerce, most people today that are listening to this won't be working for an e-commerce that have this amount of traffic. Okay, so brute forcing your way out of personalization is not an option. Second, even worse than this, people tend to not log into website, as you probably know. As in, outside of Amazon or Alibaba or Etsy, it's very hard for e-commerce to have a ratio of users that are logged in versus users that are not logged in that it's super high. Okay, so what happens is that most people are going to go onto your website, they're going to search for something, they're going to browse for something, they may or may not buy, but maybe the next time you're going to see them is going to be in 6 months. Maybe you're not going to see them for a year. So the whole idea that you have this historical data about each individual shopper, like Amazon has, and you can use that to, I don't know, guess your interest, guess your preferences, is kind of false for most e-commerce, right? So what we're left with is that if you want personalization, because again, everybody your personalization is cool and important, but you work in one of the websites outside the 5 that I just mentioned, it needs to be, personalization needs to happen as early as possible. That is, as soon as the user lands on your website, and with as little data as possible. As of course, again, by definition, we don't have much data about each user. What this means is that all the machine learning, all the information retrieval, all the NLP, all the cool stuff you want to do, now they tend to happen within the boundary of a session. While it's true that some people will have multiple sessions in a day or in a year, the vast majority of people you're trying to capture and you're trying to somehow make them buy, it's actually going to be people that are lasting on your website the span of a session. So we need to kind of rethink a lot of what we were doing, before with, with other type of technique, with what I call, in-session inference. This topic and this talk in general is a message of optimism, right? So it's a message of, you don't really need a bigger bot. Like, you don't really need 200 million users every month. You don't really need, super sophisticated, super fancy, super expensive models to actually make personalization work at your scale, okay? And what I call the reasonable scale, like the terabyte scale. You're not the petabyte scale, you're not also the gigabyte scale. You're in this kind of middle of this tail in e-commerce when you process enough data and you make enough money to make personalization a need, but you cannot, use what it do. But this is really a talk of hope, and hopefully, you're gonna end this workshop with a bunch of new tricks and new cards in your hands to deal with this problem in your everyday life. Today we're gonna touch upon some of the things we built last year, but not all of them because of normal time constraint. So what we've been doing is basically the idea that once you realize that the session is the most important thing, which it is for the reason that I explained, you need to build a session representation. And we're going to talk at length about that. After you represent the session, it is after you have a concept of a session, then you can use that to personalize basically every part of an e-commerce, from information retrieval, search, query suggestion, to recommendation, to even more fancy stuff, like index detection or causal analysis. And if you're interested, the slides are going to be released as well in open source. There's a lot of links here that you can go and check out, and it's all paper, so you can all read openly what we've been working on. Now that hopefully the problem is clear, so personalization and the constraints are clear, we need to personalize user without assuming anything that's out of a session. The first topic and the most important topic we're going to discuss today is, how do we teach computer what a session is? Okay, so imagine being a computer. Imagine being a computer and planning a website, and you see the users to the bottom of this, right? The user that is actually clicking on the shoes first, and then on the bracket, and then on the skirt, and so on and so forth, right? And the point for you is that you need to gather enough information from this click to actually personalize the entire journey. Okay, so on one side, what you can get is that this person is probably a woman, or is shopping for a woman, and then this person likes tennis, right? And this is, for us as human, is very easy to understand, but for machine, of course, it's very hard. And so the question for us is, how do we teach this kind of sensibility to a machine? And the answer to this comes from actually NLP, natural language processing. When you have a model that's called word-to-vec. I don't know how familiar you are with word-to-vec. There's tons of literature on that. But the idea is that if you consider how words in a sentence are posed, like the cat is on the mat, you have a sequence of tokens, right? And word2vec is just a simple algorithm that's going to take this sequence of token and it's going to build a space, a multidimensional space, where now words that are closer in this space are just semantically similar. So cat is going to be closer to dog in this space, but it's going to be far from Rome. Rome is going to be close to Berlin in the space, but it's going to be far from cat, and so on and so forth. And the way in which this algorithm works intuitively is that it tries to capture which word appears in similar context. So it's kind of the idea that you can tell a lot by a man by the company keeps. That's the same thing for words. Like you can tell when two words are very similar by the fact that they appear like in similar context. If you take this concept, so Mikolov 2013, like a staple of modern NLP, and you swap the concept of words in a sentence with products in a shopping session, you have Prot2vec, which is exactly the same thing. So now instead of having a space of words, we have a space of products, and products that are similar are going to be closer in this space compared to products that are very far apart. The intuition here is the same, as in products that appear close to similar products in different shopping sessions will actually have a lot in common. Imagine a second shopper here that is starting with a tennis shoes, and then they click, instead of this racket, they click on another racket. But the fact that this other racket comes after, the first tennis shoes actually tells us something about these two objects, like the fact that these rackets are close. While this seems to be very abstract, you can actually picture it very, very, very easy, right? So this is a real three-dimensional representation of a shop. Every dot in this space, so this space is projected down to 3 dimensions. Each dot in this space is a product in a catalog of an e-commerce. And they're color-coded by, in this case, by category. So by the sport, since we're using the sport apparel metaphor, by the sport they're actually for. So you can see here that the algorithm is pretty good at clustering together the violets, like the purple dots, and then the green dots in the middle, I think it's running. And then in top, you have the blue one, which I think is skiing, and the yellow one on the bottom, and so on and so forth. So naturally, this algorithm is able to cluster together, all these dots just by looking at what people do, okay? What is cool about this is that we don't need any human input for this, right? You just need to have an e-commerce, and you just need to have basically a log of what people click on during the shopping session. You take all this session, you feed them into an algorithm, and the algorithm is going to spit out basically this product space, okay? When you inspect this product space, that you go and see which products are where they are, you see that the similar product will tend to be clustered together and somehow form normal clusters of interest in a similar way as the one we discussed before with humans, right? So when you think about building a space, there's, now that hopefully the concept is clear, there's a lot of things that we need to do to make this happen in a correct way. So one thing, and this is practical tip number one, all the practical tips are going to be explained also in the second session with actual code, is that not all embeddings, not all product spaces are the same. You can see here a visual representation of this. So on the left, you have a proper train embedding space, and on the right, you have like a more confused product embedding space. This is the same catalog. It's like this is the same catalog represented here in just 2 images. But on the left side, we were able to train the model in such a way that the space captured these similarities, as you see by the color coding. On the right space, even if the data in the input is exactly the same, is exactly the same catalog, things looks a bit more confused on the right. So once we prepare this model to understand product, we need to be very much aware that even with the same algorithm and even with the same data, results may vary drastically depending on a bunch of hyperparameters that we need to set. The second point that we need to make is that, not all the product representation is going to be, the same level of quality. Why? Well, due to the long tail of interaction, not all products will be seen by the training algorithm in the same amount of time, right? So when you imagine going into the space that I showed you before, right? And then you search for what's close to that, nice blue sneaker, okay? And you find out, in all likelihood, there's gonna be other sneakers there, okay? What this means is that, again, products that are close in the space are very similar one to another. But now, if you do the same exercise, but you pick something that's very rare, let's say a GPS running watch, like the one on the right, and you go and you inspect the space and you see, well, what's around here? And then you find out that one of the objects around here is actually a GPS watch, so something that's similar, but you also find a pretty much random stuff from, in this case, scuba diving, that has nothing to do, not just with the watch, but even with the sport itself, or even with running, okay? Plus, of course, there's always the problem that new products have no interaction. So the other problem that we need to solve is, well, all this idea of product vectors is pretty cool, but how do we make product vectors with good quality when we don't have enough data? The way in which we're going to do that is by mapping our metadata, mapping the space between the catalog and the product embeddings that we created in the other way. And again, we're going to see that in detail later. But the idea here, again, is fairly easy to understand intuitively. So we know that popular products have good representation. So what we're going to do is we're going to use them as example to train basically a mapping between what happens in the catalog, let's say name, category, description, whatever, and which position in the space they occupy, okay? So we're basically building here a sort of like, let's say, Google map for product, right? So you give this algorithm like a description of a product, and the algorithm is going to tell you where in the space this product is, okay? And we're going to train a system that learns, through example, in typical machine learning fashion, to tell you where this product is based on the description. Once we learn this function, we're going to apply to the red products, okay? So now remember, the GPS watch was placed in the wrong position in the embedding space, so it was not exactly close to other watches, okay? But now that we have this, Google map for products, we're going to tell him, well, where can I find GPS watches in this space? And the algorithm is going to tell me, hopefully in a better way than before, where to find that. Okay. So with this trick, you're going to have the best of both worlds. Everything is still basically unsupervised. It's like it's really no need for humans in all of this process. But now you have high quality vectors which are learned through shopping sessions, so through the behavior of user. And then you have a low quality vector which are actually learned through this, Google map sort of embeddings that you learn thanks to the popular products. The other tip that we want to share, again, very practical, is attention when you build e-commerce cases. The search is also, of course, for recommendation, because a lot of metrics that were used normally, like in normal days, do not actually work super well to capture what an e-commerce want to do. A typical example, if you follow the literature, is that when you compare two different recommendation models, you're going to use, I don't know, hit rate or NDCG or whatever other metrics you want to use to compare them, right? So the model, you have a session, you have a training, and a test set. In the test set, you show the guy going to the model. The model is going to recommend an item, and you're going to basically, get a good score if you get the item, or a bad score if you don't guess the item. This is all good and well, and we all need quantitative evaluation. We're actually going to use the same trick later today, but there's an important product consideration that we want to make, and it's this one. When you're trying to guess the next item to do in-session recommendation, it's very important not just to be right. Of course, it's better if you're right, but if you're wrong, it's important to be reasonable, right? Which is something that is not captured at all by standard metrics. What do we mean by reasonable? Take two predictions below from, again, this imaginary sport shop, okay? In one cases, we know that the user actually interacted with the target shoes, the black shoes, and our prediction, so our recommendation would have been the blue sneakers. This is technically wrong, like we didn't really get the SKU that the user was looking for, but it's reasonable, right? Also, I mean, predicting the exact SKU in a normal e-commerce would be getting 1 out of, let's say, 80,000 items. Like, it's not even easy as a task itself, right? So we shouldn't really expect the model to be super good at that specific thing, okay? While in the second case, when the target, so what the user really clicked on was a pair of socks, our prediction was actually gloves, like something that is not just not the right item. It's something that is not even the right category, okay? So when we want to make prediction, especially about rare items for which we know that our product vectors may not be good or not, we also suggest to keep track of the cosine distance between the target and prediction in the test set as kind of like a, product heuristics to make sure that, when you're wrong, you're reasonably wrong. If you're interested in learning more about how to train good embeddings, or how to solve the problem of cold start for embeddings in the same thing, of course, please stay tuned, and we're going to talk about that with the code later on today. But you're also very welcome to go online and see our papers. We released, all of this material is not is being released in the open as part of our scientific activity. So you're very welcome to go and check out all the details of the things that we cannot really discuss today. So before we saw the product space, which again is this multidimensional representation of products where similar products are closed in the space. But remember, what we really want is not a representation of products. What we really want is a representation of sessions, because as we said in the beginning, personalization and session inference are intimately related. And I hope you really remember that, because that's kind of the most important thing of this talk. So how do we go from a product space to a session? Well, imagine following this user around in this product space, like while she's browsing your website, like your e-commerce. So she's clicking on a soccer pair of shoes, a soccer ball, a glove, a soccer shirt, and so on and so forth, right? So if you imagine seeing people browsing your website, what they're basically doing is they're traveling in the space, right? They're moving between one of these dots to another. And in many, many cases, they're going to probably just move around one specific region of this product space. And the bet that we're making, and then we're seeing later on how much it pays off, but the bet we're making is that by following people, quote unquote following, by seeing where people anonymously are in this space, we can actually tell a lot about their preferences and what they like. And we can use that insight to personalize their experience. So that's kind of the crucial aspect of all of this. Again, this is a very familiar analogy here with the geographical landscape. Like if you have a friend that goes on vacation in Hawaii or goes in vacation in, Aspen, Colorado, even by knowing this fact, which is which region of the world they're actually in, they're going to tell a lot about, it's going to tell a lot about their preferences, right? So you can make a lot of inference just by knowing somebody wants to go on vacation in Hawaii versus somebody wants to go on vacation in, Aspen or, Himalaya, and so on and so forth. And this is kind of the same thing, but the space is not the geographical space, is the product space, okay? So the way in which we're building that, we collect all the clicks in a session, so there's a user, she's clicking on products because she wants to buy or she's considering buying something. And I'm gonna combine all the vectors of the product that she clicks on and she interacts with together in a session vector. The way you should do that turns out to be not supremely important, okay? So you can, for example, think of doing the stupidest thing possible, which is basically taking the average location of all these dots, which is kind of representing, people that goes on vacation as, Rome, if they were in Italy, and Berlin, if they're in Germany, and Moscow, if they're in Russia. So it's very coarse-grained, but to a certain extent, it kind of works. Or you can do fancier stuff. By fancier stuff, you mean that you can, instead of having a normal average, you can have like an exponential discounted average, for example. So you want to weight the last dots, like the last product, more than the first one, exponentially so. Or you can even represent explicitly all the session through, let's say, an LSTM or another dense model. Based on our experience, all these things just complicates enormously the architecture without really, getting you much of a gain. But whatever we say from here onwards, you can think of using whatever combination function you want, and kind of the general product list won't change. So one case in which we can see this being useful is, you search for something on, now this example is about an electronic shop, right? So you search about something like 4K monitor, and they're sorted by relevance. Relevance is a very, of course, important topic for information retrieval. But then somehow the user goes there and just like, well, I really want to sort by price. And by sorting by price, you find out that, well, like a normal website will actually fail in this simple relevance test, right? Why? I mean, this is very hard, and there's a lot of talk even this year, and like in a specific roundtable, like there's a lot of issues and a lot of things to unpack here. And we're not interested in solving this right now in 5 minutes. What we can tell you is that even before solving this problem in full generality, which is very hard, there's a lot of things you can do to kind of like nudge the user to make the right thing, right? And one way that e-commerce websites have been using is the scoping in the type ahead. So what happens is that while you're typing your monitors or whatever query you're making, the website is going to suggest you, well, where do you want to search? You want to search in this session or in this other session? This is very helpful because if the user nudge you, so if you nudge a user to tell you where they want to see the result, relevance is going to improve because, of course, you can cut recall, right? You can cut recall by basically using, whatever category of facet, to build a better query experience. Okay, so the more you can anticipate user behavior, the more you can nudge them to do whatever they want to do, the easier it is for you to satisfy them. If you're familiar with how Google work, that's like Google works for all sorts of reasons. But one reason that Google works, that Google suggests you, always try to suggest you the proper way to phrase your query if you notice when you type, right? So Google is very good and somehow forcing you or convincing you to ask a question in a way that it knows it can answer. And that trick is very powerful. So how can it work with our, with the infrastructure and the tools that we've been building so far? Well, we can try and do what is called in-session query scoping. So again, imagine we have our shopper. Our shopper is going to the website. She's typing 4K monitor after visiting, for example, this nice monitor below. And what we should try and do is suggest monitors, right? Because that's probably the category that she wants to search on, that she's most likely to search on, right? And we have two items here to somehow represent. One is, how do we represent the linguistic intent that she has, the fact that she's typing query monitor and not battery, and the session intent, which is what we discussed, like in which region of the product space is she in, okay? Because if she's typing monitor and is in the video game category, maybe she means something very different than if she's typing monitor and it's in the laptop category, okay? Another way in which we can think of using all of our tools together, it's what it's called the discovery tags. Discovery tags are being introduced as what I think the information retrieval world called query refinement in 2020. So again, there's a user here mobile for Ravenclaw traits, and Google does a very, very, very interesting thing. So what they do, instead of just suggesting similar queries at the bottom of the page, at the very top of the page, Google suggests you some refinement that you can use to narrow down your intention. So if you do Ravenclaw traits, which is an Harry Potter thing, if you don't know, and you type Reddit, the search query is going to change in Ravenclaw traits, Reddit, and a new query is going to basically be launched. And of course, this thing that started with web search, guess what? Well, very, very quickly actually arrived in the e-commerce world. So Amazon immediately follows suit. So now for certain queries in Amazon, you get exactly the same experience. You don't have, the horrible facets. In mobile, this is particularly annoying when you have a website and then there's this horrible facet that you never know how to use. And this feature here, you see here a real example from Amazon, also kind of goes in the same type of direction. So there's a very generic query, headphones, and now Amazon suggests you before doing anything else with this tag, which feature you want to add to this. So it's kind of helping you to do that. And it's very important to realize that, again, there are two components here. One, which is, what is your intention, your query, and what is your session vector? What is your position in the product space? 60 to 80% of queries in a normal shop are 1 or 2 words. It means they're very vague. It means that when somebody lands on your website, if you have an e-commerce, let's say you have an e-commerce, let's go back to the sport apparel example. Like somebody lands on your website and the chances of them writing something generic the first time, like Nike or shoes, is actually very high. What this means is that if you want to build nice tags, words by itself is not enough. Understanding words is not enough because words will be most likely very vague, right? Remember the user before. So if the user is going on the soccer session and then she's searching for Nike, that's a different thing than if somebody goes on the tennis session and is searching for Nike. The word is going to be the same, but it doesn't mean that we should suggest these two people the same query refinement. And that happens because, again, if you go back to our metaphor, these people are visiting different parts of this, land, of this imaginary land. And so we want to take that into account. Two different people. So this is an example, the example I was just making. So two different people with two different attributes. They search for the same thing, Nike and Nike, but they get a wildly different website, a wildly different experience, which is the promise of what personalization is about. If you remember the example we did in the beginning with the real Amazon screenshot. So the female customer on the left, she's a tennis, she's a woman and she likes tennis. The male on the right, the male shopper, is a man, of course, and he likes soccer. So even if they actually use the same words, they're gonna get different tags. They're also gonna get different ranking. If you see there, even the search engine returns different result. We're not gonna talk about this, but this is also another important factor of all this. And as I was pointing out, ranking is part of personalization, as in you can imagine using the same trick to somehow rearrange things that look similar for people, especially for vague queries. We're not going to talk about it today. We already devoted an entire blog article with full open source code if you want to do that. So if you're interested in the search component of it, as in re-ranking, we kind of suggest you to go there and use the code there, and and of course reach out if you want, if you have any question, and so on and so forth. But this is another good example of why personalization is important. Two people, a very generic query, but clearly we can do better than just returning whatever Elasticsearch is doing, right? Because it's true, these people are not logged in, but these people are kind of leaving traces while they'll browse our website, and it would be very stupid if we couldn't leverage this to provide them with a better experience. Again, we kind of scratch the surface. We're going to see the practical parts of all these use cases, but there are many, many, many other use cases related to in-session or personalization. And generally, once you have a product space, there's a lot of things you can do. We refer here to two more of our contribution to the scientific community. One, which is a paper on recommendation and transformer, and the other, which is a paper on attribution, for which we're going to spend literally 2 minutes. Attribution is the problem that you all have if you run an e-commerce, if you work in e-commerce, of establishing if search was relevant for a purchase. I guess everybody here is familiar with Google Analytics. Okay, so if you use Google Analytics and you go on a website and you search for shoes, then you browse for 30 minutes and you buy a racket. When you go on Google Analytics, search is going to actually become part of the attribution for that purchase, right? Because the purchase of your racket happens in a session when you search for shoes, even if these two things are completely unrelated, okay? Which I know it's dumb, but it's kind of the industry standard, okay? So a question we asked before last year, and we made some contribution, again, some scientific contribution on, is can we use this idea of product space and machine learning to help us distinguish the cases in which search was really helpful for you to buy and which search was actually just a mere accident, like the example that I just made? It turns out that yes, you can. It's fairly complicated, but it turns out that you can do better than just Google Analytics attribution. And we think this is very important. This is very important because everybody working in search, in e-commerce, we really want to know how much how much we matter for a website. And our manager want to know how much we should invest in this. Our marketing wants to know how much we should direct people to our search part instead of other way of browsing the website. So while we cannot talk about this today, we again recommend you to, if you're interested in the topic, we recommend you to go and check it out. And it's gonna build on the same material that we just explained today. So if you got the idea of product space, you're gonna find all the rest of the material, pretty easy to understand. So before, we're 45 minutes, which is perfect. Before switching to the hands-on coding session, I'm super happy to take questions on the product use cases, on the general approach, or any other question you may have, and then we can have a small break, and then we can regroup with the actual coding part. But before that, again, please don't be shy. I'm super happy to answer any question you may have. Okay, there's message in the chat, but it's yes, but it's not question, so I think we can disregard this for now. No question. Everybody's already sleeping. Okay, I'm gonna go ahead a bit, but please interrupt me anytime you feel.
There's a question coming up, I think.
Oh, awesome.
I think it's Atita. Do you just want to turn on your microphone, Atita? You don't have to type.
Yeah, I think that would be great. So I think I really like the idea that you've been talking about, but there have been several cases where we don't need something like gender specific, or I would actually talk about the use case that we have, we are serving customers, and we usually record, their child birth dates to recommend them better products.
Okay.
Like, you have multiple kids and multiple, like suitability of the products. So maybe if you can talk about this a little bit so that I can fit this whole explanation into my use case and take more advantage.
So if you have data about your customer, that's great. That's much better than any fancy deep learning stuff that I've been doing. So if you know for certain what people do depending on a date that they specify, and you can re-identify the person across, I guess, the kid's growth and like across a lifespan, that's in a much better position than what most of my customers are, and generally what transactional e-commerce has, right? Like think about fashion, sport apparel, electronics, and so on and so forth, right? So you are in a much better position than we are. So what I would argue is that all of this fancy stuff you probably don't need, which is great. And you can get away with much easier way of personalization and with much easier infrastructure and tooling that the one will be showing. I am a great proponent of not using fancy machine learning stuff when you don't really need fancy machine learning stuff. But sometimes you need them, and that's why there are people like me, I guess. But you don't really yeah, if you have users are very loyal, I think you're better off with your with other methods than the one that we show. Makes sense?
If I can just add to this, I think the question was somehow, can I, if I buy on someone else's behalf, so I have two kids, yeah, so the parents are buying for either kid, but I don't know which one, or I buy a present on behalf of someone else,
right,
or for someone else. I think that was more or less the question.
That was, yeah, I was actually writing that my kids are 4 and 10, but I want to buy presents, or I want to explore.
Oh, sorry, I thought you have an e-commerce when you have the date of the people, and then you can recommend people to them, like shops, like baby shops do. Sorry, I misinterpreted the question. Yes, that's a good point, and honestly, there's no particular. I mean, if you imagine this case, you buy something for your kids that's 10, so you start browsing in the, I don't know, 10 years old session, which probably is going to get you better recommendation than the one in the 4-year-old session. And then when you want to buy the other kid a gift, you go into the 4-year-old session, and so your session is going to be 4-year-olds kind of tailored. So unless your kid are born in the exact same day, which is going to be like an extreme unfortunate coincidence, I think you should be fine. Like, it should be fine as long as your session is somehow self-contained. All these methods will work very well. In fact, we're gonna show, like, if you go to the paper, there's details on how well they work on exceedingly annoying benchmark. So you can go and read how good this is on a real website. The more your sessions tend to be intertwined in their intent, the least this is going to be useful. Yes. I hope that's a better answer.
Yeah, that helps. Yeah, that's what I have felt as well, looking at the results that we have so far.
There are a few more questions in chat. Do you want me to read them out, or do you want to read them yourself?
That would be lovely. So because I'm really bad with Zoom chat and so on. So if you can do it for me, that would be lovely.
Okay. So Kahan Baksh asks, can you explain a bit more about the function F that you guys use at Coveo to map product vectors in a session to session vector? What worked and what didn't? Thanks.
Absolutely. So we're gonna see a bunch of let's go back to. Does it work? Yes, one sec. Let me go. Oh, yeah. So let me go back here. So this is a template, right? This is a template of an architecture that has two components. One is a representation of linguistic behavior. In this case, it's for query scoping, but you can think of search. It's the same thing. And the other is a representation of the session vector. Okay. Then you need to combine them in some way, and you need to make a prediction. Okay. In this case, the prediction is a category, but it can be different things. Okay. You can swap in and out architecture here and kind of keep the same idea. And there's no guarantee that all architecture, like one architecture, is going to be the best one across all use cases. So let's start with the example of the query vector. Like one representation you can use is pre-trained model, let's say pre-trained BERT. Another thing you can do is word2vec. Another thing you can do is LSTM, and so on and so forth. And you can basically run all the benchmark, keeping this idea intact just by swapping representation. With the session, which is what the question was originally about, but just to make a parallel here, is exactly the same. You can keep the same idea, which is what really matters, intact, and trying basically all possible combination that you have. What we have tried personally is simple average, weighted average, as in exponentially discounting, as I was explaining. So recent projects are exponentially more important than other one, and even for explicit LSTM. So we actually also try to encode this and have a full, deep layer whose entire job is basically mapping the sequence of the product to adding the representation, and then you feed that, to something else downstream. We tried all of that. All work-ish, but the marginal gain you get from training an additional STM and how slow that is at real time does not in any way outweigh the cost of running that. So everything you're going to see later on today, or in most of our paper, it turns out to be a weighted average, okay, which is a good trade-off between how fast and how easy it is to do versus the result that you get.
Okay, the next question is from Andreas. Do I get it right that you could essentially use the same approach to federate sessions across languages? So low traffic languages get boosted by the high traffic languages. I think this refers to the
yeah, that's a very good question. That's a very good question. So if you go, I'm gonna see your question. I raise you one. So if you go into the paper called Fantastic Embeddings, what we do is we actually show how you can map two websites that are completely unrelated. One can be low traffic and one can be high traffic. And you can use this idea of the things you learn in one session to follow user across website, right? Which is a bit insane, but it kind of works. But the idea is that you can kind of implicitly transfer what you learn in one space and transfer it on another space, provided it is isomorphic enough, and you can kind of translate all that gain into the other place. At least you can do better than just popularity or stuff you would do when you don't have any data. So yes, there's evidence for that. It's a bit complicated, but there's also open source. There's also an open source repo again on that thing. So you're super encouraged to go there. And if there's something that doesn't check out, please reach out to us. But yes, that's a very good point.
Okay. The next question is from Venkata. Will there be any bias in the session data that we capture?
Can we define bias? As it is a word that has many meanings. So bias means, I don't know, more female in a fashion store, for example, or more male in a soccer store. Maybe, but we don't really know that, right? There's no data that we get from the user, like zero personal data that we ever collect from the user. There is not a sequence of click. So of course, our method and our session representation are going to reflect what is the general population of the website. So if the general population of the website tends to be severely skewed in one sense or the other, we're going to inherit that, like all machine learning models. And there's kind of not. So, and if you, let's say, if you're a very rare user, if your patterns are very rare and you land on a website, yes, there's the chance that this method is not going to work supremely well for you because it's been trained on what everybody else does. But that's also true of network recommendations.
Okay, next question from Ila. Hi, how do you treat different user intents during one search session? Like a user can search for irrelevant items during one session, milk, shower, milk, shoes, flowers. Do you somehow split it into separate sessions? What to recommend then?
It's a very good, so this is a very, very good point. So first thing, how many sessions in your website are what we call cross intent may wildly depend. And one way in which you can actually very easily calculate that, if you have product space, so by leveraging these tools, is you can chart where people move on your website. Okay, now you have a product space, and you can basically measure, what distance they cover in a session, right? If at some point they jump from one part of the space to the other, it typically means they change intent, right? So actually, the tools that we showed are very easy, are very cool to quantify that. If that percentage needs, somehow seems to be, like very high, like high enough to warrant like a separate method, well, you can use the same intuition that we explained. So you can exponentially discount events, which meaning that, the most recent events are going to weight way more than the past one. So the website is going to basically adjust, very quickly to what you're doing. B, since you detect this huge jump in the product space, you can even reset the product session vector, right? You can even reset the session vector. You can basically treat them as 2 sessions instead of 1. Technically, it's 1 session, but you can totally split them in 2. As a practical thing, we didn't do neither of this, even if we thought about this. And it would be fairly easy. But again, what we show, it's going to be fairly easy if you want to implement it.
Okay, great. Next question from Andrea. Do you have some kind of reset of the personalization so users don't get stuck in a personalization loop? So for example, I was looking for a specific sports shoe, found one and added it to my cart, ordered it, and then I'm looking for a normal sneaker. How do you make sure I don't see sports shoes only from there on?
That's kind of the same type of things, as in you go full. This is an happy customer, so you go full and add to the cart. Like, you go almost to the full thing of one item, and then you say, well, now I want to shop something else. And if it's within the same session, I would repeat what I just said, as in, if you heavily discount the past, this thing will kind of automatically set back to, go back to a normal level very quickly. Or you can even decide that, let's say, after an add to cart, you can reset the thing. We did not do that, as depending on your website, but again, making bold and stupid generalization, but in a lot of website, in a lot of e-commerce, a lot of people buy 1 or 2 things at most in the same intent. So depending on the website that you're running, this may be false, okay, or true, but that will kind of, let you decide if it's worth the trouble of, of splitting sessions internally or not.
Cool. That's the end of the questions.
Okay, cool. So hopefully, again, the slides are going to have the slides, but hopefully by this time you have downloaded this, and so we can go into the coding part. Before that, and that's the last marketing slides. So what are we working on? So we briefly touched our roadmap, and we're gonna see a bit more of that even in the end of the session. We are a very small team, but we work with a lot of people, as we have a very open and liberal policy on collaboration, intellectual property, data, and so on and so forth. This year, we really like to work on small data problems, query semantics, and experimental platforms. So if you want to work with us on any of this topic, like these fine gentlemen and ladies did last year, we are super happy to reach out and you know and try and we can try and see if there's part of our roadmap, part of your roadmap that overlap, and we can write a paper together or do some research together. And we're super happy to talk to you. So please don't be shy. If you think there's something here that rings a bell, like reach out. So I'm gonna change my screen now. One sec. So I stop sharing. This is chemistry. Okay, one second. Chat. Oh, okay, so this is everything that was done. Okay, I'm gonna do 1 minute pause for everybody. I'm gonna get some water. This is very warm in New York. Gonna be back at 2 exactly, and we're gonna share a different screen with the code, and we're gonna walk to the second part of the workshop. Again, it's gonna be technical, but not super technical. So even if you're a product, like we're not gonna go into super tiny details about the code, but even if a product person want to attend or somebody not technical to attend, but you just want to get a feeling of how easy or how hard it is to translate what we just said into actual code, please tag along. Okay, I'm gonna see you in 1 minute. Here I am again. Yes, 2 minutes, so I think I can start again. So for those of you joining now, I don't think how many of you will be joining now, but just as a recap, so we're in the second part of our hands-on personalization workshop. In the first part, we went through a lot of slides and a lot of chat, a lot of concept around the idea of personalization for e-commerce. In particular, around the idea of personalization when users are anonymous, so you cannot track them through time, and you don't have that much data. So you kind of need to be a bit of smart, a bit clever to provide personalization within this constraint. Hopefully you downloaded this, you cloned this repo already. We're gonna go through this particular file here. If you didn't, no problem. It's open source. It's there. You can use it whenever you want. If you don't do it now, If you didn't download the data, please do, for the same exact reason. So again, if you're doing it today, you can totally do it, at a later stage. And if you find us useful, please tell everybody about this data set and this code. We're super, we did it to share with the community. So the more it's shared, start it on GitHub, share it with your friend. This is a really cool data set, and it's a really cool thing that we did this year for the community. And so we can't wait for people to use it more. You should see my notebook now. So, and we're gonna go through some of it, and we're gonna highlight some interesting stuff that happens when you run this notebook with the data that we just show you. So you can download the data, you put them in a specific folder in your laptop. It's gonna be this one. So you need to change this line here, okay? So once you unzip your data, you're gonna change the line here. You're gonna install the requirements from the requirements file, and then you basically can run it in a notebook as much as you want. This other parameter here is going to tell the code that follows how many rows from the original file to read. Why is this important? Well, it's important because we don't want to wait like 2 hours to run the tutorial. And the file that we share, the browsing session that we share, are like a lot, like 30 million events or something like that, which is cool, but it's really too much for really too much for this tutorial. So if you want to run it quickly just to see that it works, you can just make this number as little as possible. This is a reasonable number to see some result, of course. And if you want to run it fully, you can basically make the number of the rows in the data set, and it's just going to read it all. Okay. So the first thing we're going to do, again, hopefully you remember our slides, is building a product space, like building a product space of what representing the product. So we don't really care about this, as in you have it. What I want to show you here is this one. So this line here, so line 19 and following, is how we build the prod2vec space. A curious thing about this function is that this function is actually called word2vec, because it is literally word2vec. It is word2vec from a package. In this case, word2vec, there are like 25,000 implementation for that, even Spark if you want, or Sage, or there's an Amazon implementation. But if you use the classical Python NLP tools, you're probably going to use Gensim, which is the standard for word2vec implementation. And you see here, one of the parameters of Gensim is sentences, because of course Gensim is an NLP tool. But as we discussed before, we're going to kind of turn this NLP tool into an e-commerce tool by substituting sentences with sessions, with shopping sessions, like quite literally. As you can see, the code is, it tells more than 1,000 words in this case. Right? And then there's another bunch of hyperparameters, which are the standard hyperparameters of the model, okay, and which we're going to discuss about that. But it's really crucial that all the cool space that you saw before, the three-dimensional space and so on, it's produced by literally one command in a standard library that you can download. So it's also very easy. And word2vec scales very well. So even if you have a lot of sessions, it's gonna be working pretty fast. We don't really care what happens here. We don't really care. One thing we want to show here, again, we're super happy to look at this, but this is a 2D representation. So it's less fancy than the 3D black one that you saw before. But this is exactly the same type of idea. So what we did here is that we train our nice prod2vec model, okay, which we trained here, okay. And then what we did, we used this helper function, again, don't care, it's standard Python, to project down this space. This space is in 48 dimension, as in each product has 48 coordinates. Unfortunately, human cannot really visualize that. So we need to bring the 48 coordinates to 2. And we do that with a standard technique, which is called t-SNE, okay? You can use the standard library to perform this transformation. So the transformation will go from 48 to 2. You see here, number of components, 2, okay? Once you have that, okay, now you have 2 dimensions, which means now we can plot it, on an image, right? Because 2 dimension, human can visualize 2 dimensions. It's like, X and Y in a standard, in a standard plane. And once you color code the SKU by the category, you're gonna see here that it's not bad, right? So there's a bunch of, bit of noise in the middle, as you can see, like some overlapping. But generally speaking, you can see that even in 2 dimensions, so even by losing a lot of information through this compression, the prot2vec algorithm is pretty good at clustering together things that have the same color, right? Where the same color in this case means things that belong to the same category, okay? And it did that with no manual or human label, right? This clustering, like the building of this space, it was just done by reading through session information, like what people clicks, and by running the the one-liner that we saw above. Okay, so this is pretty impressive, and I mean, you can run it on your code. So it's not just a fancy, fun slide to see the mock-up that we saw with the lady before. This is actually something that can materialize in your browser in literally like 100 lines of Python. Most of the lines of Python are actually needed to draw this, not to actually compute it. Okay, if you do the same thing, but now denoising a bit. So now we just took the prot2vec product with just the top 5 categories. So the categories that are most represented in the data set. You see here how the algorithm is very good at distinguishing between this. Okay, so there's clearly some information that is being captured by this whole idea of product space. And we're going to see how to leverage it for all the use cases that we mentioned. As a bonus, again, since this is a practical workshop and we really want people to get something they can use tomorrow out of it, we also set up, we're not going to talk about this, but there's also an alternative way in which you can make inference in a prot2vec space. So the typical ways in which you can make an inference in prot2vec space, sorry, for those of you who are not accustomed to embeddings, is you basically just ask the space which are the closer product in a space. So imagine you have this. I hope you can see my mouse. I hope you can see my mouse. So if you're here and you ask, I don't know, you ask, what is the closer product to this blue line here, blue dot here, and you're gonna get, I don't know, these 10 dots here, okay? So this is the way in which you do that. It turns out that it's not super fast. So if you really want to do this often or with very low latency, you can exploit the same idea, the same model. You're just gonna make one change, which is gonna be this thing here. It's called annoy indexer. And you're basically gonna use that to query for vectors. Of course, now there's some approximation. So you get much faster inference. So if you want to know which products are similar to other products, now it's gonna take way less time, but it may contain some errors, okay? That's a trade-off that you have to pay. If you see here, in this case, we run the standard Gensim version, the one that you get automatically, against the annoy version, and this is the seconds per query. So every time you ask the model to give you back similar products, you see that annoy is way faster than that. It's like more than 4 times faster than Gensim. So if latency in any part of your pipeline is a problem, this is a nice 3-line trick of Python that will take the prot2vec model that you train and make it much faster in inference time. The second bonus topic that we're going to discuss, we mentioned it, if you remember the slides before, is hyperparameters tuning. Okay, remember the slides when there was like 2 product phase, one was like neatly separated, and one which is like, oh my God, this sucks. Everything is kind of on top of each other. So how do we make sure that we produce one and not the other? Why is this a tricky question? Why is this much trickier than what one could think with normal models? The answer is that because the prot2vec space are completely unsupervised, it's not exactly clear what it means, to build a better prot2vec space, right? If you think about the standard classification model, right, when it's very clear if you're classifying something as a cat or a dog, then it's very here to validate models, right? You just have other dogs and cats picture, and you're gonna see, which model performs better. But here, there's no ground truth. Like when we build this product space, is this some sort of unsupervised clustering that's kind of happening behind the scene? So how do we tell which one are better or not? Of course, we can print them out, and like in this case, like one is better colors and the other is not. But first, doesn't really scale, and second, better colors is not really a scientific measure of anything. So we need to find like somehow a better way to do that. So the way in which we're gonna do it is twofold. Again, if you're interested into the super detail, please go and check our paper and our repo. But one is quantitative, and it's the idea that a prot2vec space that has been built properly will be good at recommendation. We're going to discuss this in a minute. And the second one is qualitative, which is one product space that is being built properly is going to be able to separate the catalog into meaningful categories automatically. Okay, so let's go first one to much easier one, which is the quantitative one. So imagine again, we train this product space, we have all these dots. Remember, we're here, literally we have these dots, like literally in the memory of my computer, there are these dots now. Okay, and the way in which we're gonna see how good these dots are is by taking sessions that the model has never seen. Okay, and then we're gonna tell the model, well, get the last item in this session. So imagine people clicking, and then get the item before the last one. Okay, and then we're gonna feed to the model the item before the last one, and we're gonna see where in the list of similar products the item that was really clicked is. Okay, particularly we're gonna use iterate. Okay, and what is this encoding? This is encoding the idea that if the product space really, clumps together products that are kind of similar in the mind of shoppers, it's going to be very easy to predict the next item of a shopping session just by looking at this space. Okay, I hope that's as the intuition that kind of rings a bell. So here, I mean, this is not a real one, but you can modify this in a way that suits you. Here we're taking just one of the hyperparameter that we want. In this case, is how many iterations we run. And we basically run a model with the same training session and with the number of hyperparameters that we decided are needed. So in this case, it's like for each iteration of these hyperparameters, we're gonna have 1, then we're gonna have 10, which are fake value, we don't really care, but just as an example. And then we're gonna calculate. So the model that we get by training, so line 6 here, we're gonna feed it to this function, which is gonna calculate the iterate on what is called NEP, which means next event prediction task, which is what I just explained. Like given a product, what is the next product? And we're gonna pick the model. So our hyperparameter validation is gonna work by basically picking a set of hyperparameters that's gonna get us the best HR. If you see here, I mean, this is a trivial example, as obviously more iteration, like 10 iterations in the skip gram bit 1, okay? But you can see here how you could expand this to other things. So you can see here the iterate is 0.26, and here is 0.4. Like it's a significantly better iterate than it is, okay? Which means that the hyperparameter 10 is superior to the hyperparameter 1 in this, in this particular case. If you imagine doing this for all the hyperparameters that we saw here, again, we did that for the paper, so please go and check it out. But if you want for all this, okay. Back here. Okay. Oh, before going to, yes, we didn't include this, which maybe we could do that after this. But yes, so the qualitative version, which is not here, is exploiting a different intuition. So let's go back to the image here. Again, real image in your browser. Okay. So imagine, and you have the color coding here. It's just the category that the merchandiser put like on the products in the catalog. Okay. So this has been labels that has been there for navigation and browsing. These have nothing to do with NLP or AI. Okay. And the way we use them to color, because intuitively when a merchandiser thinks that two products are related, they actually are related because it's their job, right? And again, and that shows that if colors are homogeneous, the model is kind of learning this by itself, which is great. So you can think of taking this a step further. And now you go into the catalog and you just don't take the category here, the one that's color coding here, but other facets that you deem are important. Go back to our example of sport apparel. Some items are for both, male and female. Some items are all for males, and some items are all for females, right? That's very easy to establish, like looking at catalog. So a good product space intuitively is gonna encode this information in the relative position of the item. So somehow in this 48-dimensional plane that we cannot really visualize, there must be something there that encodes the fact that some items are male dominated and some items are female dominated. So what you're going to do, you're going to train a small neural network, let's say a multi-layer perceptron, that giving an input, a product vector, one that you just train, is going to tell you male or female. And you're going to compare that prediction with what merchandiser put in the catalog. And then you're going to do this for, I don't know, the price. And then you're going to do this for whatever you deem important, okay? And this gives you, of course, a quantitative evaluation, as at the end you're going to have an accuracy measure, but it's a quantitative evaluation that reflects the qualitative things, the merchandiser things are important in your shop. What you should find is that product spaces that has been trained properly are actually very good at this. If you properly train a product space and then you do the dumbest possible classifier on that, it's gonna detect, let's say, sport activity, soccer versus, I don't know, basketball in this case, very, very easily. Okay, remember we're all running from the slides with this analogy of sport. Like, we don't really care. Like, this is not a sport thing, but the general gist applies, right? And so this is another way in which you can test if the product space you built, color coding aside, which is this one, it actually reflects the common intuition that we have. I saw there was like a question. Oh, you. Sorry. Go back to my talk. Okay. Is there any question, please, guys? Again, like this is we do this live so that you can interact. So
okay, there already is one.
Awesome.
From Tekudan. How do product vectors get trained when there are errors in the spellings of names, descriptions of products entered by merchants? Also, how do we handle out of vocabulary?
Sure. So product vectors, as we've been training them up until this second, so up until here, don't have zero catalog information, zero. Product vector are trained only on session data. We can go back here and verify that what I'm saying is actually true by looking at this function here, which takes the CSV that you can download for free, and it's gonna just tell you, okay, which product people are gonna use, which is this one. The only thing that happens here is that we're appending the product SKU to a session, which cannot be mistyped because it's kind of generated by the website when you click on PDP. I mean, can be mistyped as in a bug, but not as in a typo, okay? That's the only information that we have. The only information that we have is for millions of users, the sequence of SKU they visited during a shopping website. That's the only thing. So when you get back here, user session, this thing here, okay, get fed into your trained PROTVEC model. So there's no information that every human has ever put in to get this nice space here. What you need the catalog for is for the nice color. If you don't care about the colors, there's no manual or catalog information that goes into that. We just do the colors because since we also have the catalog, we can use them again for this nice visual check. But in the catalog, this is just categories. So there's no type, like, this is not something that people type. This is basically the structure of the website. Imagine a do-it-yourself website. This is gonna be kitchen versus bathroom, okay? There's no product description, there's no name. The color here just reflects a category, okay? In fact, if you look at the file that you downloaded, you're gonna find that this category is not even expressed in English. It just expressed as a code, okay? So there's no human effort in this whatsoever, and there's no human information that went into this. I hope that's clearer. But very good question. People get confused all the time. There's any other question? Go. Okay, cool.
I think this is one to leave for the end. There's another one, but let's ask this at the end.
Okay, cool. Yeah. So
wait.
What is?
Okay, so let's do a round of questions. I think some of the questions do not necessarily relate to this step in the flow somehow, but go back to the beginning, but let's do it right now.
Of course.
So Sebastian is asking, how do you handle non-linear sessions? So sessions where the order of product viewed has low meaning, like think grocery shopping, where the discovery navigation is close to zero.
Very good point. We don't have, at least I don't have, even with dozens and dozens of deployments, ever work in the grocery space. So I don't know the space well enough to tell you if that is, if that hunch, which looks intuitively correct, is also, generally correct. As in, I can totally see people, I don't know. I can totally see people buying, potatoes and meat, because one goes with the other. So it's not exactly the same as fashion, but I can totally see some regularities there. But I have no experience with that, and none of our benchmark relates to that. If you do, and you want to try our method, please let me know how it goes.
Okay. Next question. Your strategy of using merchandiser categorization to validate, qualify the product vector space is really inspiring. Have you ever considered encoding human merchandiser labels to help with products that don't have a lot of user session interaction?
Absolutely, and this is what this improving low count vector is going to be about. Yes, that's correct, and it's what we're going to do in a second.
Okay, that's it.
Okay, cool. So thanks for the question. The question is actually particularly appropriate because it introduced naturally what we're going to try and do, as in, well, a lot of product vectors do not really have a lot of clicks, right? Which doesn't mean that we cannot build a vector. It means that the vector we're going to build is going to be low quality, where quality means it's not going to encode all the nice things that we want him to encode. Remember what we discussed before? If you go into, again, let's go back to the sport apparel fake website for sake of argument. If you go into the sneakers session, every dots in this space here, if you imagine this being sport, every sport in this space is going to be a sneaker. But if you go into the GPS watch session, again, pretending there's a GPS section here, when you go and look at that, you're going to see, let's see, you see my mouse here? Maybe GPS watches are here. You see here, there's a lot of colors here. It's not a particularly well-defined part of the space, right? Compare this with the orange part here on the top left, right? All orange things here are probably going to be very similar, right? Well, here, there's a bit of noise, okay? So how do we improve that? There's no way, first, one thing that's very important, there's no way that we can solve this problem in its full generality, because there's always the case of vector of product with zero interactions, right? So let's remember this. Like, there's no amount of data. Like, this is a problem that Amazon also has. Like, this is not a small data problem per se. As in, every website, it doesn't matter how big, is going to face a problem at some point where new products comes into the catalog and we don't have any information about them. Okay, so that's a problem for everybody. Okay, so one way in which you can solve it, if you really like this product space idea, is not really to change the product space. You're going to keep the product space, but now we're going to replace some of these dots. Let's go here. We're going to replace some of these dots, not the orange one. You see the orange one in the top left, they're good. We're going to replace some of these red one here, random red one here, with dots that we learn from the catalog. So we're going to use the merchandiser description label categories, or even the images, if to learn a better position from these dots, right? So maybe once we move it, these red dots here, I hope you see my cursor. The red dots here is not going to be here. Maybe we move it here, all with the other red thing, okay? Because maybe we detected that that was a bad vector, and now we move it there. Okay, so this is what we're going to do now. So we don't really care. Okay, so what we're going to do here is that we're going to divide the SKU in popular versus non-popular. Is line 3 of 27 cell. Okay, so we're gonna say that the product that are in the 80 percentile, you can see this here, okay, will be the product that are popular. Again, we care about popular not because we care about popularity, but we care about the fact that popular products will typically have good representation for the vector. Okay, and then we're gonna read from the catalog, which is also being released to you, so you can do it. We're gonna read a representation of the description and representation of the image as well. So we're gonna take what the merchandiser thought it was a good image and a good description for this program, and we're gonna use it, okay? And the way in which we're gonna use it, well, don't really care, but is by building basically autoencoder that join images and description, okay, concatenate here, and basically try to predict like where this item is in the space. Okay. Again, imagine this space again. Okay. We're building something that, given a catalog description, is going to produce a dot into this picture. Okay. And the idea is that since we train on the orange things, which are really well together, we can learn what everything else is. Okay. Even things that are not well together. And that's the trick we're going to exploit. So once you do that, but you train it, blah, 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 I'm not going to train it live, but you can do it yourself. Okay. Then you can basically get a new product space. And the new product space is going to be a product space that is going to be a combination of the old product space, the one we trained above, but now you swap out the vectors that you think are rare, okay, the vectors that you think are not very good, okay, with the vector you just made up, okay, made up as in the vector that you kind of, the points in the space that you kind of, you know, produce by this synthetic way of doing that, okay. And now you have a new version, and you can, of course, you can run again the same, you know, the same calculation, right? You can find out if and how, you know, the hit rate actually improved, or if and how it improved, even when you consider only the rare cases, right? Like how good it is with the rare cases. In this particular example, you're actually going to get a worse result than the original one. This is due mostly to the fact that the representation of the catalogs that you find are not as high dimensional as the one used in the paper, because the representation has been released, has been morphed for several reasons. But the general principle holds true. And if you're really interested in the architecture, again, I suggest you not to just look at this, but look at the Rex's paper from last year. The general idea, we think it's sound, which is, if you really like this product vector idea, there's a lot of information encoded in Merchandiser that you can use to improve your vectors. And this code here should get you started in doing that with your own catalog and your own high quality description. So again, this is mostly of a bonus topic, as in it's very important, but it's also required a certain level of sophistication. It requires you to be so acquainted with the problem embeddings that you now realize that some of these embeddings are, you know, low quality.
I think this time I want to ask a question myself. Sure. Have you tried just using images and not textual information? So my observation often is that text is very noisy, and images somehow lie less. And could there be a benefit to just using images?
Absolutely. Images, especially for similarity, are actually very good, especially in some verticals, like fashion is a clear example. So when things that are similar tend to be also very pattern-like, like very similar pattern-like, yes, it may be a much better thing. Again, and thanks so much for the question. We're not really trying we're trying to establish here principles and best practices, but deep learning is not an exact science, as in it may totally be that the same concept would work for you with a bigger embeddings, with a different autoencoder, or just images, just text, and so on and so forth. What we're trying here is providing you hopefully a cookie cutter, like a template, where it tells you, if you like this personalization, you know, in-session personalization thing, this is working code you can start with that works on real data. It may be that your data is different, or you have different insight that we don't have because it's your data, and it's super encouraging you to do that. But there's no presumption here that this thing works for everybody. It works for what we tested and for what we published, that we can say, but we're super open to other version of it. So if there's another question, we're gonna go into a, you know, maybe harder, or I wouldn't say more complex, but model today, which is query scoping. Query scoping, we go back, remember the slides. So there's a person that is searching for 4K monitors, and we want this person to not search for 4K monitors. We want this person to search for 4K monitors only in the specific category of desktop computer or gaming or whatever we want. And the way in which we're going to do that, we're going to nudge this person on the type ahead of clicking on the category that we think she likes the most. And the category she likes the most is a function of two things. One, what she's writing about. Like if she's writing about monitor, we don't want to suggest keyboard, right? Because, you know, that's a different thing. And the other thing is, as we said, the session, like the information that she encodes in the session, right? If she's writing Nike, it doesn't really narrow it down, but if she's writing Nike from the soccer part of the website, that's going to tell you something that's different from writing Nike in the tennis part of the section. So how do we combine these two ideas to produce something that works? Again, stupid code that's just gonna read data from the file that we released. The file that we released also have query data. So also have actual I think it's like almost 1 million of query, like real query that people did on the website, showing which product they clicked on and which product they saw but not clicked on. So if you want to also do research on what is called pseudo feedback, there is positive feedback and negative feedback, our dataset also supports that. The only way which we're using this for now is to learn a training set in which we're gonna go back in history. So we're gonna go back into our data set, and we're gonna find session where people click on products, as we discussed, they search for monitor, and then they click on a product. And we're gonna read on the catalog the category of that product, so that now we can build a training set. The training set is, we're gonna feed the model, the session, and the query. So product A23, ABC, and query monitor. And we're gonna ask the model to predict the category that was clicked after the user made that query. So it's very easy for us to, just by search logs, basically the one that we shared, to kind of come up with a training set for this model, which is convenient because, as you know, building a training set is always, is always a pain. And the way in which we're gonna do that is we're gonna basically then build, again, this is like a very stupid model, and this model is gonna try and predict that, and it's gonna make, so this is the first version of the model, which is just gonna take in input the query representation. So this first version doesn't have session, it's not contextualized. So two people that have the same query are gonna receive the same suggestion. And it's just gonna try to predict one of the many classes. This is a standard one-not encoding representation. One of the many classes is per team, right? So in particular, here we cut at 40 categories. And so you can imagine this model as a model when you tell it monitor, and it's gonna get you, I don't know, category 13, which is monitor. If you do Nintendo Switch, this model is gonna tell you gaming, okay? And so on and so forth. So this is kind of the idea. And once you build the first version, which is this one, you can go back to our idea of the session contextualization, and you can build a more complex one with session info. So now, instead of having instead of having Nintendo Switch gaming, now you're gonna have a bunch of products, which is what the user has seen, the query, and then the contextual inference. Again, stupid blah blah blah. We're gonna read this file, blah blah blah, same thing, and we're basically gonna build the same exact model. Again, super simple Keras model. Even from this simple example, that the accuracy on the same exact condition with the same model has been bumped up by, I think, 5% between these two cases. So as it's even clear by this, very, very trivial model and, super simple training routine, adding session information actually helps the model disambiguate better, which is a general lesson that we learn at bigger scale and, with more realistic model. But you can totally already see it here, going through a search log, how you build a training set, how would you train a model, and how would you feed also the session information to improve it, to improve the accuracy of it. And that's all the code I have for today. But I'm super happy. But I'm also pretty sure I'm confused even more. So I'm super happy to, take as many questions as you want.
So I think this was very inspiring, and I think many of us will try this out at home. So are there any further questions? Please put them into the chat or unmute yourselves. Doesn't seem like that. So anybody having questions about running the notebook, maybe? No. So I would say in that case, I'd like to thank Jacopo once again, and probably you can reach out to him. I think he left his details. So thank you very much.